And the last descriptive statistic that we want to look at is no longer a measure of center. We have what's called a measure of deviation, or the standard deviation. And what the standard deviation means is it tells us on average, and I'm going to use the word average like you guys have used it in the past. So on average, it measures how far the data points or statistics but how far our data values are from the center. So these data values that we're measuring with these statistics, we can look at how far on average are they from the middle, whether that be the mean or the median or the mode. But in this case, we're going to use the mean as our measure of center. So we're going to use that idea of mean. And we can calculate standard deviation. However, very few people would choose to do it by hand. And again, we'll look at some tools and technology that will make our life easier here. But what we need to do is we need to make sure that we find all the deviations. So we're going to take the sum from I equals 1 to n, because we have n values in our list. And a deviation is the difference, or how far it is from the actual value. So I'm going to take each data value, x sub I, and we're going to figure out how far that is away from the mean. And I'm going to use x bar here. And we're going to know that x bar is the mean of a sample. And your book chooses to use little m. I'm going to use x bar because we're going to see that in the future. And then we're going to square it. The reason we square it is to make sure that all these differences are positive. We would rather have all the values be positive so they don't cancel each other out. And then, again, I said I want to take the average of how far those data points are from the center. So I'm going to add them all together. Right? Take the deviations, square it so that they're positive, add them all up, and then divide by how many. But since I squared it, I don't really have the true value that I'm looking for. So what we're going to do is we're then going to take a square root at the end to scale that back down to get rid of that squared. So if we look at a data set here, for example, if we have a data set S that has the values 1, 2, 3, 4, 5, 6. We could quickly get the average here. And I'm going to change that first value to a 2 to make it a little bit nicer average. We've got 6 plus 4 is 10, plus 5 is 15, plus 3 plus 2 is another 5. So that added in there is going to make 20 and 22. So to get x bar, we have 22 divided by, and I guess that's not going to be nice either. Let's change this to a 4 in the front. So we've got 24 divided by 6 values. So we're going to get an average of 4, or a mean of 4. So we've adjusted that in our example since we get to pick the data to make it a little bit nicer to work with. Notice that 4 would have also been the mode in that case, and it would have also been the median. So here we have one where all 3 measures of center match up, which is nice. Now to find that standard deviation, we have to take the square root, and breaking apart that sum, what we have there is we have the first value minus x bar squared, plus the second value minus x bar squared, plus the third value minus x bar squared, plus the fourth value minus x bar squared, plus the fifth value minus x bar squared, plus the sixth and the last value finally minus x bar squared. And then we're going to divide all that by 6 because there were 6 values. And again, you can see why with a small data set, it looks like it's a lot of math. With a large data set, we wouldn't choose to do this by hand. And so we have 0 squared, which is 0, plus negative 2 squared, which is 4, and negative 1 squared, which is 1, 0 squared, which is 0, 1 squared, which is 1, and 2 squared, which is 4 again. I'll divide by 6. And so we have here 4, 5, 6, 10 over 6. Or we could reduce that to the square root of 5/3. And I guess we could punch that into a calculator if we had to have a decimal number, but I'm just going to leave it at that. So we have a standard deviation, which means that on average, each of these data points up here in our data set is the square root of 5/3. Now, 5/3 is a little bit less than 2, and the square root of 2 is like 1.3 roughly. So we're a little bit less than that. So on average, each data value is a little bit more than 1 away from the middle, which seems to make sense. I mean, 4, that's 0 from the middle. This one's 2 units from the middle, 1 unit from the middle, 0 units from the middle, 1 unit from the middle, and then 2 units from the middle. So it makes sense that somewhere between 1 and 2. And that's it for this section. Next time when we look at notes, we'll look at using the calculator and Microsoft Excel to make these calculations a little bit easier. Or we might look at that in class as part of our in-class activity. So we'll talk about that later, and I'll see you then.